Hey everybody, in this video we are going to do one of 8 examples of transformed parent functions. So let's get started. So this one you have p of x equals -2 times the square root of x plus 8, and then on the side plus 4. So the parent function is what? Well, the parent function is y equals the square root of x. That should be known right away. Now you need to know, what does the square root of x look like? If you are interested, actually, let's pull this on the screen. This right here is what the parent function of x basically looks like, okay? That is just plain old y equals the square root of x, okay? So from that, you can deduce and figure out, Dallas, you can figure out that, come here, the pattern for drawing it follows a certain look, right? So let's hide that. And do you want to come here? You want to help me? Okay. Okay, thanks. So the parent function is at the origin over there, and up 1 over 1, up 1 over 3, up 1 over 5, and continue with the odds. There is no arrow on the left side. It's a closed point, and it looks something like that. Why does that happen? That is the distance between the perfect squares. So we go from 0 to 1 to 4 to 9 and so on. And I promise, if you keep going down the list of perfect squares, they are odd increments apart. So when we're doing a square root graph, when you go sideways, you go up by the increments of odd numbers. And if you're doing parabola x squared, you go up by the odd numbers, okay? So that right there was what the square root of x looks like. Now let's list out our transformations. So the transformations, I'm going to start with inside of my square root. That's the x minus h. So that's going to move my graph to the left 8 units. And then the plus 4 on the end, that's my plus k, right? So that is up 4, right? And in case anyone needs, you have a square root of b parenthesis x minus h plus k. And that is what the structure essentially is. A is your vertical stretch, reflect, compress. B, horizontal stretch, compress, reflect. X minus h moves you left to right, plus k up and down, and so on, okay? So we have that. Now we have 2 more transformations. The other 2 transformations have to do with the negative and the 2. So the negative, that's just going to go on the side, okay? The negative is a VR, which is going to be vertical reflection. And then the 2 is greater than 1, so it's a vertical stretch by a factor of 2. If it was inside horizontal, which we don't see very often, you use the reciprocal of b, okay? So now let's get this graphed, okay? So if we wanted to get this guy graphed over here, what are we going to do? Well, I'm going to start off by moving to the new, like my little crosshair, my new starting point. So that's going to be left 8 and up 4. So 1, 2, 3, 4, 5, 6, 7, 8, and up 4, and up 4, 1, 2, 3, 4. So right there, that's where, I'm looking to make my kind of new origin. So I'm just going to draw a little plus sign right there. It's my little crosshair. Okay, and now to draw out my new transformed square root graph, I'm going to start with the point, my starting point that was at the origin before. Normally, again, I was up 1 over 1, up 1 over 3, up 1 over 1, 2, 3, 4, 5, and so on, right? So it would look something like that, but that's not what we're dealing with. We're going to reflect vertically. So I'm going to reflect it, doing it this way over my new x-axis, if you will, okay? So I'm going to go down, not down 1 over 1, but I'm going to go down 2, vertical stretch. Everything that was 1, 1, 1, up, 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 it's going to be 2, 2, 2, down, down, down. Everything's times 2. Down 2 over 1, down 2 over 3, down 2 over 5, down 2 over 3, 4, 5, 6, 7, and there you go. and then no arrow at that starting point. The square root graph does not have an arrow at that starting point, only over here. If you put an arrow, you're going to mess up your domain and range. So your domain describes your graph moving from left to right, the x values. Now I'm going to label this -8. I'm going to label this 4 because if you mess up, if you labeled, at least I knew what you meant, right? Those dots, heavy and dark, I don't have any question about where they're located. Domain is from -8, including -8, until positive infinity. That's the left to right part of this. And my range goes from bottom to top. The bottom goes from -infinity, it's down forever, until +4, and again, the 4 is included. Now there is an absolute maximum point at, let's just say it's at, we're going to give the coordinate for right now, -8, 4, and no absolute or local or anything minimum in this graph because it goes down forever. That is the end of this example. Hopefully you feel good about it. If you're happy and you know it, thumbs it up. And I'm going to record the other 7, and I will have a quizzy posting soon. I just realized I didn't post it after school, so I will post it right after I do the videos. Okay? Yeah, bye.